Welcome to a course of communication system. Here we will study analog communication as well as digital communication system. First we will start with what is communication and then we will continue. Okay. Uh, Communication system. Communication system, when we say communication system, it means that a system which transmit our message from point A to point B, that is point A to point B, and it is there is some the point B is at some far away from point A. Okay, and the communication, uh, whatever we want to transmit from point A, maybe it is voice signal or it is audio signal or it is message video signal. It may be another signals such as image or another things, but these are the main signals what we transmit through point A to point B. Okay, if you talk about communication system block diagram, then communication system block diagram, uh, we can say that first will be we have source, what we have to source signal, what we have to transmit. Then we have a source transducer, and then our channel, and at the receiver side we have a receiver transducer, and then we receive the message signal, received signal. Okay, this is the basic block diagram of a communication system. We will classify this block diagram into AM, analog signal, and digital signal later on. Okay, first we will study one each and every block diagram to understand what is this. First, source signal. Source signal may be voice signal. The voice signal is what we are saying right now, what we are speaking, or whatever our voice is. We want to transmit this voice signal, and the frequency, the voice signal lies the frequency in which the voice signal lies is approximate 20 hertz to something 3.5 kilohertz. It is a very low frequency basically. Then we will say about audio signal. uh, the audio signal, the recorded signal, audio signal, just we are saying that something, not only voice, but our audio signal lies between 20 hertz to 20 kilohertz. Okay, next is our video signal. Video signal lies between 0 something 0 over 20 hertz. It is a 0 to something 4.5 megahertz. Okay, we will talk about what is frequency, bandwidth, and how we transmit the vast frequency using our uh, using modulation. Okay, first we have to understand, okay, and then what is source we have talked about source signal, then source transducer, and receiver transducer. Transducer, basically, what is transducer? Transducer used to convert our message signal into electrical signal. Whatever we have, suppose we have voice signal, we have audio signal, we have video signal, we convert into it into electrical signal, then we can say it a source transducer. It convert into electrical signal. And the reverse process, in which electrical signal is converted back into voice signal, audio signal, or video signal, is called receiver transducer. Here, receiver transducer. Okay, and the received signal is, after passing through receiver transducer, we have received signal in the form of voice, audio or video signal. I hope it is clear what is communication system and the block diagram of communication system. Now we will see there are basically two types of communication system we see in our practical domain. Two types of communication system. First one is our wired communication system, and second one is wireless communication system. Wired communication system and wireless communication system. In this course, our focus will be on the wireless communication system, not on wired communication system. In wired communication system, our channel is either twisted pair, copper copper wire, optical fiber. These are the main channels for the wired communication system. In wireless communication system, we have just a transmitter antenna at the source, and there is a receiver antenna at the receiver end. Okay, if we talk about wired communication system block diagram, it is similar to our communication system block diagram. But if we talk about wireless communication system, then we have a message signal. There is a message signal or source, our whatever we have source message signal. Then we have transducer, source transducer. Then one important block diagram is here, that is modulator. And modulator, in which we have source the output of the source transducer and the carrier signal. We will talk about what is carrier signal, and then what is modulation and types of modulation we will see later. Okay, and then we have a transmitter antenna. What we have already told, that there is a transmitter antenna by which we transmit our message signal, and in the reverse process at the receiver end we have a receiver antenna, then demodulator. In demodulator, either we use carrier signal or we in some cases we do not use carrier signal. We will see that one. And then we have receiver transducer, and then our received signal. Okay. I hope it is clear the block diagram of the wireless communication system. In wireless communication system, there is a need of modulation. Why? The question is why? Why there is a need of modulation in wireless communication system? In wired communication system, also there is a need of modulation, but wireless communication system, it is the mandatory to use a modulation. Okay. What is modulation? Why there is a need of modulation? First, we have to understand modulation is basically to transmit our low frequency signal into high frequency signal. What we do, that we use a high frequency signal, that is also called carrier signal. We either we use their amplitude, phase or frequency. We alter these components using our message signal, that is our low frequency signal. Okay, why there is a need of modulation? I've asked so many times why there is a need. The main reason is our antenna size. Antenna size. Why? Why antenna size is main hurdle for wireless communication system? Suppose we have a dipole antenna, then dipole antenna, what we have is uh, in which the height of the antenna can be determined by lambda by 4. Okay, suppose we have a message signal f is equal to 15 kilohertz. We have taken 15 kilohertz message signal. Okay, then what will be the lambda? We can calculate lambda using the formula V is equal to f into lambda, and lambda is equal to 3 into 10 to the power 8 divided by 15 into 10 to the power 3, which is approximately, I am not going to calculate, approximately 5 kilometer. Okay, then can we think about the 5 kilometer size of antenna? We cannot think about that. Okay, then how can we reduce the size of antenna? We have to reduce the size of antenna by using modulation. And what modulation does? Just shifting our low frequency signal into high frequency signal, so that we can change the value of this 10 to the power 3 to some higher value, so that our size of the antenna is reduced. Okay, I hope now you will understand why there is a need of modulation in case of wireless communication system. Okay, next one more term I want to introduce here, that is multiplexing. Actually, this term is introducing because this it will be used in our course many times. That's why I am using here multiplexing term. Multiplexing is basically we are transmitting more than one signal in one channel. That is, there is a multiplexer here, multiplexer, and there is a more than one input signal, input 1, input 2, so on. And there is what we are doing, just we are uh, we are transmitting all the signals in single channel, single channel. And at the receiver side, what we have, we have a demultiplexer, by which we split all the signals, all the input signals in the form of output to output signal 1, output signal 2, output signal 3, so on. Okay, I hope now you will understand, you have understood what is multiplexing and multiplexing process. Okay, it basically mixing the signals, input signals, and then at the receiver end it splits all the mixing signals. Okay, now one more term I want to introduce here, that will be used in our course, that is Fourier transform. In signal system course, we have already understood the Fourier transform and the process of Fourier transform. I will here only introduce in just introduction form. Okay, the Fourier transform basically convert time domain signal into frequency domain signal. It convert what we have in signal in time domain. Suppose this is a signal in time domain. In using Fourier transform, what we do, just change, we change the we do not alter the signal, but we change our the perspective to see the signal, that now we are seeing it into frequency domain. What we have in we can see the same signal in what are the components lie into this time domain signal using Fourier transform. Okay, and how we will convert the time domain signal into frequency, the frequency Fourier transform in Fourier frequency domain signal, that is defined by xf is equal to minus infinity plus infinity xt e to the power minus j 2 pi ft dt. This is the process by which we convert time domain signal into frequency domain signal, and this process is called Fourier transform. Okay. uh, just we are seeing one example here only, and we will limit, then we will continue later in next class. That for suppose we have a time domain signal is a square signal, that is minus t to t. Okay, and this is I am writing it t1. Okay, this is t, this is our xt, and our amplitude is 1. I want to convert into a frequency domain signal. It means we want to calculate the Fourier transform of this signal. How we will calculate the Fourier transform? We have to write this formula. Xf is equal to, now it is minus t1 to t1, or we can write here minus t by 2 for simplicity, tau by 2 to tau by 2, minus tau by 2 to tau by 2, then it is minus tau by 2 to tau by 2. The duration of this signal is now tau. Then xt, in this duration our message signal value is 1, and 1 into e to the power minus j 2 pi f t dt. Okay, I hope it is clear, there is no doubt. Accepting this except this limit, we have the what we have the value of xt, that is 0, so that we have kept the value, the limit is has been kept from minus tau by 2 to tau by 2. Okay, now just we want to calculate the value of this. Then when we want to calculate, then first we what will be the integration value, the e to the power minus j 2 pi ft divided by minus j 2 pi f, and our limit is minus tau by 2 to tau by 2. I hope it is clear, na? And the value we put e to the power j 2 pi minus j 2 pi tau by 2 minus e to the power minus minus plus j 2 pi f tau by 2 divided by there is a negative sign here, j 2 pi f. What we are doing, just inserting minus here and plus here and removing this minus sign. Just we know that e to the power j x is equal to cos x plus j sin x. Okay, just using this formula we can write here what we have, e to the power j 2 pi f tau by 2 minus e to the power minus j 2 pi f tau by 2. Am I right? This is the situation, divided by j 2 pi f. Now this is cos 2 pi f tau by 2 plus j sin 2 pi f tau by 2 minus cos 2 pi f tau by 2. This is a minus sign, minus, there will be minus, and there is a minus sign here, the plus j sin 2 pi f tau by 2 divided by j 2 pi f. it will be cancelled out, and what we will get, 2j sine 2 pi f tau by 2 divided by j 2 pi f. J will be cancelled out, 2 will be cancelled out. What we will get, 1 by pi f into sine 2 pi f tau by 2. Okay, and what we can write here, sine 2 pi f tau by 2 divided by pi f. Here what I am writing here is basically uh, tau by 2 and 2 by tau. I am writing here 2 here. Now it is tau into basically tau into sine 2 pi f tau by 2 divided by 2 pi f tau by 2. This is called sinc function. Actually what we'll write here, sinc x is equal to sine pi x divided by pi x. We can write it as tau into sinc f tau. Okay, that is 2 is cancelled out basically. Now we can write here sinc f tau. And what is the graph of this function? This graph will be like that. This is the graph of sinc function. It is decreasing. Okay, and this, what is the value of this one? This is basically f xf. Okay, we can say amplitude. Okay, and this is value of 1 by tau. This is basically 2 by tau. This is 3 by tau. This is minus 1 by tau. This is minus 2 by tau. This is the basic graph of this signal, of the Fourier transform of this one. For today I am stopping here. I hope from today's lecture everything is clear. If you do not understand any point in my lecture, then please comment, and I will try to answer all those questions in our next class. Thank you for watching.